Good day, Mom. My name is Dr. John G. Guevara from the program DS Mechanical Engineering Code 2118. So, for today, we will discuss the chapter 5 of the lesson, which is Geometric Designs. And we will be focusing on the transformation, the introduction of transformation. So, before we start, what is transformation? For me, transformation is the process of changing the object or changing its direction or distance without changing its appearance or shape. So that's transformation. So at the end of this lesson, you will know about how does transformation works, different types of transformation and their function. So you will know about the how does transformation works on geometric or in the graph and different types of transformation. So we have the different types of transformations and their functions. So we will know that later on the end of this lecture. So transformation. Transformations in geometric transformations is a change of its size, orientations, or position following certain techniques in mathematics. So in this statement, following certain techniques in mathematics, so without breaking the rules of mathematics, the object will change its size, orientation, and position. So what are transformations in math? A function's f that maps to itself is called the transformation. F is to x. The pre-image x becomes the image x after the transformation. These transformations can be any or combination of operations like translation, rotation, reflection, and dilation. Rules of transformation. Consider a function's f quantity x quantity on a coordinate grid. We use the x-axis and y-axis to measure the movement. Here are the rules for transformation. So here are the rules for transformations of functions. Transformations can be represented algebraically and graphically. Transformations are commonly found in algebraic functions. We can use the formula of transformations in graphical functions to obtain the graph. So in algebraic expressions, we apply the transformation also. So we transform the value to another value. So as well as in the transformations in graphical functions, which is to obtain the graph by just transforming the basic or the parent functions, thereby move the graph around rather than tabulating the coordinate values. Transformation helps us visualize and learn the equation in algebra. So that's the rules of transformation. So here are the different types of transformations. So first is the translation. A translations from the word translation, it is to translate the object or to move. A translation moves a shape up, down, or from side to side, but it does not change its appearance in any other way. So in translation, the object or the object will move down, up to either side or to other side, but it does not change its appearance. So that's the translation. So translation is an example of transformation. So another example is an example of transformation. Transformation is a way of changing the size or positions of the shape. So, so that's transformation. Every point of the shape is translated the same distance in the same direction. So every point in the shape is translated the same distance in the same direction. Same distance and same direction. So same distance, same direction. We'll see it in the picture below. So describing translation. Column vectors are used to describe translation. 4 over negative 3 means translate the shape 4 squares to the right and 3 squares down. When we say 4, this is the x and the negative 3 is y. So 4 is move, so move the shape to the right. So 4 times. So 1, 2, 3, 4, and move it downwards. Move it down 3. So that's translation works. Vectors are given in the form xy, whereas vectors are given in the form xy, where x is the movement horizontally and y is the movement vertically. A position value of x means as movement to the right, and a negative value of x means a movement to the left. Positive value of y means a movement upwards, and the negative value of y means a movement downwards. So vector is given with the value of x, y. So a positive value x, if the value is x, it moves to the right. If it is a positive value. If the negative, if the x is negative, it will move to the left. So, and a positive value y moves upward, and the negative value y moves downward to the graph. So, another example is rotation. So rotation, when we say rotation, the movement twists or rotates in a certain degree. Rotation turns a shape around a fixed point called the center of rotation. Rotation is an example of transformation. It's another example of transformation. So let us see in the image. As you can see in the image, the object rotates in a given degree, in a degree which is 90 degrees. The shape has been rotated 90 degrees, a quarter turn clockwise, about the center of rotation. So that is rotation works. That's how rotation works. So we'll proceed to reflection. A shape can be reflected across a line, a reflection to create an image. When we say reflection, if, for example, as we can see, as we see ourselves in the mirror, we see a reflection. So, as what we can see is this is what we can see in the mirror is this the same perspective that we have. So the line of a reflection is also called the mirror line. So the center line is the mirror line. The triangle PQR has been reflected in the mirror line to create the image. So so look at the picture. The quadrilateral triangle PQR is reflected to the mirror line. So same distance, same degree. So that's how reflection works. So in the second image, you can see that the object is reflected on the mirror line. So same angle, same degree, and same shape. So we will proceed on the glide reflection. So glide reflection, a combination of a reflection in a line and a translation. So the glide reflection is the combination, both translation and reflection. A perpendicular direction is a reflection in a parallel line. So as you can see in the picture, um, the quadrilateral triangle reflects and translates to the side. So that's glide reflection. However, a glide reflection cannot be reduced like that. Thus, the effect of the reflection combined with any translations in a glide reflection with a special case, just a reflection. Dilation. So when we say dilation, it has two types, the reduction and the enlargement. So dilation is a transformation of an object by resizing to either reduce it or to enlarge it about the point with a given factor. The value of factor quantity determines the dilation is enlarged or reduced. So this is the enlargement and reduction of dilation. Enlargement or reduction is a transformation in which a size of an object is changed without changing its original shape. So enlargement from small small to big, and the reduction is from larger object to smaller object. So it change its size, but it doesn't change its original shape. If the size of an object increase, we call it enlargement. And if the size of an object decrease, we call it reduction. So that's how enlargement and reduction works. So these are the examples. These are the examples of translation that are given, that I search and given. So some examples of translation. Just look at the example one, the picture. This shape is translated to the right side. So the equation is a to b equals to 6 over 0. So 6, the 6 is the x. So we will move it to the right side. The x is not negative. So we'll move it to the right side. So 1, 2, 3, 4, 5, 6. So this is how to translate the object in the graph. Another example of translation. So example 2, let's look at the picture with objects. So C to D equals to 0 over negative 4. Therefore, we conclude that negative 4 moves downwards. It moves downwards. So the y moves downwards. So this is the reference point. 1, 2, 3, 4. So this is how translation works. So this is the example of rotation. 90-degree rotation clockwise. Based on this picture or in this graph with the given objects, the quadrilateral triangle rotates clockwise with a degree of 90 degrees. So, and this another picture is 90-degree rotation counterclockwise. So the object or the quadrilateral triangle rotates counterclockwise. This is another example of rotation, 180-degree rotation clockwise and counterclockwise. So it's based on this graph and these objects, the quadrilateral triangle object rotates clockwise and counterclockwise That conclude that concludes that the both quadrilateral triangle has in opposite side. So clockwise and counterclockwise. Examples. So these are the examples of reflections. So figure 1 shows a triangle shape at the right hand side of the y-axis pre-image that has been reflected over the y-axis line of reflection, creating a mirror image. So as you can see in the image, the triangle, the quadrilateral triangle reflects to the other side, the same given distance and with the same shape and value. So on the reflection, we have to copy. We have to copy the position or to morph the position. So another example is triangle P has been reflected in the line X equals to 4 to give triangle Q. So triangle P and reflected to triangle Q. So same distance, same position. So this is the example of bright reflection. So for example, reflect the given image along the black axis and then move it 6 units down. The glide reflection of the blue image is the green image. So as based on this picture, the uh, the object reflects and glides downwards. So this is the glide reflection. This this red object is the glide reflection. And the second example is this quadrilateral triangle. So the triangle A reflects and glides downwards with the same angle and with the same shape and distances. And the last example is the dilation, which includes reduction and enlargement. Find the scale factors of the circle with the measurement given in the figure. So as the given example, we conclude that radius of this circle is 3 units. If we enlarge it, it will become 6 units. So we see the circles increase in the size, therefore the factor is dimension of new shape divided dimensions of the original shape. So if we reduce it or we use reduction, we divide it to the dimension. So in order to come up with these 3 units, which is 2. So another example is this triangle in the graph. So the triangle PQR is in this size, and if we enlarge it, it will become bigger or it will become higher the value. So this is the end of my presentation. I hope you learned something. Have a good day.